This question is from GATE 2018 Mechanical Engineering paper set 2, question number 32. In a cam follower, the follower rises by h as the cam rotates by delta radians at constant angular velocity omega radians per second. The follower is uniformly accelerating during the first half of the rise period and it is uniformly decelerating in the later half of the rise period. Assuming that the magnitudes of acceleration and deceleration are same, the maximum velocity of the follower is. Let's find out. So the total rise is given as small h. So for the first half, we have rise will be h by 2 and for the second half also it will be h by 2 for each half. That means if we are to represent it in terms of displacement, it will be displacement for first half is equal to displacement for second half is equal to h by 2. This denotion comes from the formula for displacement from the equations of motion. So s is equal to ut plus half at square. We know that u is initial velocity, t is the time taken for s displacement to occur, and a is the acceleration. So now we can substitute s1, s2 here. It is h by 2 equal to initial velocity will be 0 because initially it is at rest, half a. Now the time taken for this h by 2 displacement to occur is half of the time. So we substitute in place of t, we substitute capital T by 2 whole square, where capital T is the time taken for complete rise h to take place. Therefore, we have value of acceleration from here will be at square by 8 equal to h by 2. So, a will be 4h upon t square. This is the acceleration. Now, we know that angular velocity omega is nothing but displacement per unit time, and time taken here is capital T. So, from here we know that t is theta by omega. Because theta and omega are known, t is not known. So therefore we substitute t in terms of theta by omega. Substituting it here, we have 4h upon t is nothing but theta by omega whole square, which is equal to 4h omega square upon theta square. So we have the value of acceleration here. Now we need to find out the velocity. Let's do it. Using the equation of motion for velocity, that is v square equal to u square minus 2as. V is the final velocity, u is the initial, and again acceleration and displacement as we used them previously. U is 0 as already mentioned. So v square is equal to 2as. Now s is again s1, s2, that is h by 2. So after substituting value of s and a, we will have v square equal to 2 into 4h omega square by theta square into small h by 2. So this becomes 2 by 2 gives us 1. 4 times h into h is h square, 4h square omega square upon theta square. Now one thing to change here is that theta given in the question is delta. Actually it is given in terms of delta. So just a matter of notation. We will have a final velocity value in terms of delta, that is v is equal to under root 4h square omega square delta square. All of them can be evaluated for the under root. So it is 4 root is 2, root of h square omega square by delta square is nothing but h omega by delta. We have the answer of velocity here. So let's go back and mark the correct option. Our answer is given in option C. The maximum velocity of the follower is 2h omega by delta. To learn more about kinematics of machines, you can refer to the NPTEL video, Module 10 Lecture 3, Kinematics of Machines, from the course lecture series on Kinematics of Machines by Professor Ashok Kumar Malik. He is from Department of Mechanical Engineering of IIT Kanpur. I hope this solution will help you clear your doubt. Thank you.